My name is James Malone. I'm a product manager in Google Cloud, and today I'm here to talk about Google Cloud Dataproc. Specifically, I want to talk about making Apache Spark and Hadoop fast, easy, and cost-effective. So these terms are really easy to throw around, and you'll hear them frequently in pitches for Spark and Hadoop, and I want to qualify them a little bit in the talk today. So first of all, let's talk about fast. In Google terms, fast should mean that things take seconds or minutes, not hours, days, weeks, or months. In Google terms, easy means things should be operable with as little research as possible. You should be able to intuitively use something. You shouldn't have to go read a lot of complicated documentation. You shouldn't need to go hire specialists. You should be able to point, click, and go. Cost effective. You should pay for exactly what you use. You shouldn't pay for the nearest hour. You shouldn't pay 1 year or 3 years out. You shouldn't make best guesses about what you might need and pay for it right up front. If you use 30-some minutes of a resource, you should pay for 30-some minutes of a resource. There's multiple ways to run Apache Spark and Hadoop on Google Cloud, and I kind of want to talk about some of the ways here in building up to Cloud Dataproc. One of the first options is running a third-party Apache Spark or Hadoop distribution on Google Cloud. This is something like a Cloudera or Hortonworks distribution. When you do this, you'll take advantage of the underlying Google Cloud technologies like Compute Engine, cloud storage, maybe BigQuery, but you're running your own cluster, you're managing your own cluster, and you're generally running a lot of components on that cluster. The second option is what we call BDutil. It's a set of command line utilities that allow you to create, manage, and use Spark and Hadoop clusters on Google Cloud. With BDutil, we give you generally vanilla components in the Apache Spark and Hadoop ecosystem, but you're still self-managing your own cluster. The third option is our fully managed Spark and Hadoop service, Google Cloud Dataproc. Google Cloud Dataproc is a fully managed Apache Spark and Hadoop service that allows you to create Spark and Hadoop clusters, submit work to those clusters in a way that is fast, easy, and cost-effective. Cloud Dataproc is a really neat product in Google Cloud Platform because it brings the power of the Apache Spark and Hadoop ecosystem to the rest of the rich portfolio of Google Cloud Platform products. So let's unpack this a little bit. It means that you can use Apache Spark and Hadoop with our awesome operations tools like Stackdriver monitoring and logging. It means that you can look at your logs from your cluster in Stackdriver. You can look at monitoring metrics for your cluster in Stackdriver. You have really first-class monitoring and operations tools surrounding your Cloud Dataproc cluster. Moreover, these are the same operations tools that are going to be used with other cloud platform products. You don't have one-off solutions all over the place, especially with using the Apache Spark and Hadoop ecosystem. We also have a really neat set of storage technologies in Google Cloud. These are things like Google Cloud Storage and Cloud Bigtable. These allow you to read and write data from and to Cloud Dataproc clusters easily. It means that you have the ability to share data in something like Cloud Storage and use it across multiple products, including Cloud Dataproc. It means that if you're putting your data in cloud storage, you can use Apache Spark and Hadoop on it, sure, but you can also read and write that data in cloud storage in any other Google Cloud Platform product. Third, we have a rich set of data products. These are things like Google BigQuery or Google Cloud Dataflow. They give you truly unique, differentiated, and powerful data products that you can use in conjunction with the Apache and Spark ecosystem. The important point here is you're not using the Apache Spark and Hadoop ecosystem in isolation. You're using it with a really rich cloud platform that offers you first-rate services across a whole set of needs. Ultimately, for the Spark and Hadoop experience, this means that your data in your cluster is not an isolated data lake. It means the data you put in cloud storage or BigQuery or Bigtable. It means your logging and monitoring. It means your enterprise data warehouse in something like Google BigQuery. It's all connected together. Your Spark and Hadoop cluster is not an isolated island. It's part of a larger community of cloud products that you can take advantage of for a multitude of purposes. So let's look at what this might mean a little bit deeper. With Cloud Dataproc, I could read and write data from and to a number of places. For instance, if I am familiar with HBase, I might use Cloud Bigtable to read data into a Cloud Dataproc cluster. I could use cloud storage as a replacement for the Hadoop file system. I could use BigQuery as my enterprise data warehouse. In terms of the ops side, I might ship my Yarn logs over to Stackdriver logging. I might use Google Cloud Dataflow in conjunction with Cloud Dataproc for both batch and streaming analytics. I might use Cloud Dataflow to stream data and pre-process it, and then use Cloud Dataproc after the fact, connecting to BigQuery to just examine a subset of data in something like Spark SQL, because I'm really interested in using something, say, in Spark ML. The ultimate point here is Cloud Dataproc is very well connected with the rich set of cloud platform products. And it really brings the power of the Apache, Hadoop, and Spark ecosystem to the other product offerings that are in Google Cloud. What this means for you at the end of the day is something that is very important. You can spend time with what actually adds value to your business. That is understanding, using, and taking action on your data. Managing infrastructure, keeping engineering teams simply to wrangle that infrastructure, worrying about scaling, those things are not necessarily going to add value to your day-to-day business. So with Cloud Dataproc, you can use the Apache Spark and Hadoop's ecosystem in a way that allows you to be truly hands-on with your data and not the tooling that you use to run the Spark and Hadoop ecosystem. So this ultimately means with Cloud Dataproc, you're very easily able to lift and shift your workloads from wherever they may exist in a Spark or Hadoop cluster. It could be on-premise. It could be in a hybrid cloud between on-premise and another cloud. It could be in another cloud entirely. But ultimately, since with Cloud Dataproc, we give you a vanilla Spark and Hadoop distribution that we patch and make sure had fixes and speed enhancements applied to it, of course. But it allows you to take your data and your workloads and easily move them to Google Cloud. You could take, for example, a Java MapReduce job that processes data and move it to Cloud Dataproc without rewriting your entire job. We want the rework to be as minimal as possible. And in many cases, it would take probably on the order of just a few minutes to get up and running on Cloud Dataproc with your existing code. Let's look at some of the features and benefits of Cloud Dataproc. Some of the features of Cloud Dataproc are inherent to Google Cloud Platform, and some of them are more specific to Cloud Dataproc itself. But the nice thing, again, since Cloud Dataproc is solidly built on cloud platform technologies, you get the best of both. So in terms of Cloud Platform itself, these are things like per-minute billing. These are things like low compute and overall Dataproc premium charges. It means that you pay for exactly what you use, and in general, you'll probably pay less comparable to many other solutions. It means that you inherit some of the great benefits of Cloud Platform like our security and control and awesome networking. All of this is instantly and immediately available to your Cloud Dataproc cluster because you're running in Google Cloud Platform. Some of the other features are more specific to the offering of Cloud Dataproc itself. These are things like being able to use preemptible virtual machines with Cloud Dataproc, being able to access the latest and greatest enhancements in the Spark and Hadoop ecosystem without waiting weeks, months, or quarters to do so. There are things like being able to use Cloud Dataproc with the rich set of cloud platform technologies without having to configure drivers, without having to install connectors, because all of this is bundled together on your Cloud Dataproc cluster. It also allows you to easily submit and monitor work in your Cloud Dataproc cluster without having to open terminal windows or use third-party applications to submit and manage your jobs. With Cloud Dataproc, we make it easy not only to manage Apache Spark and Hadoop clusters, but we also have a wrapper around the work that you may want to run on them. This provides a number of benefits to you. First, it's very fast. Since you don't need a team to go run your Spark and Hadoop infrastructure, it means that you can get started with the Apache Spark and Hadoop ecosystem very, very quickly. It also means that you can create an Apache Spark and Hadoop ecosystem which matches your need anytime that you actually have that need. It also means that you pay for exactly what you use. If you use just a fraction of a day worth of Apache Spark and Hadoop time, you can pay for that fraction. You're not paying to simply run and have the access to the cluster all the time. So if I were you, I would say, why does this matter? Why does any of this really matter? I have a Spark and Hadoop environment. It seems to work okay for me. What matters specifically about this that is applicable to me? So first, let's look at what a traditional Spark and Hadoop cluster looks like in terms of going from the need to either create or scale a cluster to the point at which you're able to actually use that capacity. In a traditional on-premise setting, it's a very long and often complicated process. First, you focus at the hardware level. You have to get your servers, you have to put them in your data center, rack them, then configure them. Once the hardware is done, you start looking at the software. You install the open source components like Spark and Hadoop. You then have to configure all of those components and get them optimized to the hardware, your network, how you've racked things. From there, once it's all set up, you probably start testing it and seeing how it's working. Probably and most likely, you're going to realize there's things you need to tweak. So you're moving into the debugging phase. This is where you're going to go back and change those settings, test, rinse, and repeat. Only when you're really satisfied you worked out most of the bugs are you ready to use your cluster. Usually this doesn't take hours or even days. This is something that in many cases takes weeks. Even if you're using virtual machines in a data center, it can take quite a long time because you have to wrangle the software, you have to wait for it to deploy. This is a process which means that if you have an immediate need to use Spark and Hadoop, you have work that you want to run, a job, a query that you want to write, the time that it takes to get to your end result is often hours, weeks, days later. With Cloud Dataproc, we've tried to keep things very simple. First, you create your cluster. As I mentioned, in many cases, this takes less than 90 seconds. Second, you can configure your cluster, but this is an optional step. This is more of a power user step. This is where you can choose the specific machine types that you want in your cluster. This is where you can install additional software on the cluster. You can configure custom settings, but you don't need to spend a lot of time configuring your clusters. In many cases, you can configure your cluster, like add or remove nodes, with just changing one text field. From there, your cluster is ready to go, and you can start using Apache Spark and Hadoop. So going from creating your cluster to using your cluster, in most cases, even if you configure it and you change some of the settings, say you want to put things in a different zone, you want to install some additional components, that's not going to add any real additional time to use your cluster. So you're ready to go from create to use in just a few minutes. So as an example, if I were on-premise in my previous example and it were Monday, I want to use Apache Spark and Hadoop. In the best case, it might be Wednesday or Friday until my cluster was ready to go, until it had been debugged, until we had made sure that everything was up and running. With Cloud Dataproc, you create the cluster, and with the click of one button, just a minute or two later, you're ready to go. There's almost no waiting in between. So let's look at how this benefits the three things that I previously mentioned, being fast, easy, and cost-effective. First, let's take a look at fast. Scaling a cluster can be kind of tricky. So say I have a cluster and I need to know how much I want to scale that cluster for my capacity in 3 months. With a traditional cluster, you often have to make your best guess. You have to assume how much you think you might need and go provision your cluster to have that capacity. And the lag time in that provisioning can be on the order of weeks or months. With Cloud Dataproc, you can scale your cluster anytime. This includes creating and destroying your cluster. So I could create a cluster, add a bunch of resources to it, remove a bunch of resources from it, or delete it. All of these operations take a minute or two. We're not talking about hours, weeks, or months. So this makes it very fast to both add and remove capacity in your Cloud Dataproc cluster. Let's look at hard versus easy. So this scaling problem that I've mentioned, it can be very hard to figure out what scale you might need. So for example, say it's January and I'm trying to create a cluster that I'll be using for quite a long time, but I'm trying to figure out how much capacity I'll need in December. That problem can be very hard to solve. But with Cloud Dataproc, if you have work to do, create a cluster, run your work, and delete your cluster. There's no need to keep a cluster when you don't need one. Third, let's look at costly versus cost-effective. So the scaling problem. There's really two approaches that we could take to the scaling problem in a traditional cluster. One is we can over-provision our cluster, where we add additional resources to the cluster. We may not use it today, but we are pretty sure we might use it. Well, this means that you're probably paying for resources that at least at some points you're not using. The second option isn't much better, which is under-provisioning our cluster. This means you're probably going to be in a situation where you know you have work that you want to do, but you don't have enough resources to go do it. Neither one is really that great of an option. But with Cloud Dataproc, since you can create and modify and remove clusters quickly, plus since we also have per minute billing, this means that you can pay for exactly what you use and scale at any time. This ultimately ends up being highly cost effective because your cluster utilization will dictate exactly what resources you can decide to put into a cluster, which will equate to exactly what you pay for. So let's look at how we do this. This is Dataproc under the hood. First of all, Cloud Dataproc is built on the foundational building blocks in Google Cloud Platform. So these are things like Google Compute Engine, Google Cloud Storage, our stack driver monitoring and logging tools, and our awesome networking. So when you create a Cloud Dataproc cluster, the cluster itself is built on Google Compute Engine. This is really great because this means that all of the benefits for Compute Engine, these are things like preemptible virtual machine types or custom VM types where you can specify the exact number of CPUs and the amount of RAM in a cluster. Since we are built on Compute Engine, all of these features are inherently available to Google Cloud Dataproc. On top of these components, we've layered a Dataproc agent. This is really the glue between the Google Cloud cluster that you create on Compute Engine with persistent disk and cloud storage, and the open source components. This is what allows us to create the cluster, monitor the cluster, submit jobs to the cluster, and know what's going on with the cluster. This is really the glue that holds Cloud Dataproc clusters together. On top of that, we have our open source software stack. We use Apache BigTop to build essentially a vanilla Apache Spark and Hadoop distribution that we install on top of Google Cloud Dataproc. Our agent talks to this open source software. So we use Apache Yarn as a resource manager, and the Dataproc agent directly talks to Yarn to do things like submit jobs, monitor jobs, commission, decommission nodes. So we've tightly integrated Cloud Dataproc to make it a powerful but not overweight experience. We're not demanding that you install an overweight large Hadoop distribution here when you simply want to use a few components within the Apache Spark and Hadoop ecosystem. Now you can install additional components if you want to, but we don't want you to have to run an overweight cluster for things that you might not actually need at that point in time. Since we have this agent that is integrated with the open source software and the hardware below it, we have an API that allows you to submit some of the most common job types to your Cloud Dataproc cluster. These are things like Spark, PySpark, Spark SQL, Java MapReduce, Pig, and Hive jobs. So if I have, for example, a Hive script, I can, through the Cloud Dataproc tools, submit my Hive script without opening up a command line window and using the Hive tool, or trying to use some complicated web interface simply to use Hive. We wrap all of that. Moreover, the output from these jobs are streamed to the Cloud Dataproc tools that we offer you, which I'll talk about a little bit later. With Cloud Dataproc, you ultimately can do a couple things with the data that you're processing on your clusters. First, you can put the data back in other cloud platform products. So for example, say I read a bunch of data and process it with Java MapReduce, I could go write that data back to Cloud Storage or Bigtable or BigQuery. Second, when you create a cluster, you can run as many jobs on that cluster as you want. So I could have one job feed data to a second job. Third, with Cloud Dataproc, you can install additional software components when you create the cluster. So for example, I might want to run Apache Zeppelin or Jupyter on my cluster. You could do that. And with the job output, you could have that pipe to those applications that are running on the cluster. In terms of pricing with Cloud Dataproc, we've tried to keep things very simple. Cloud Dataproc is priced at 1 cent per virtual CPU in your cluster. So for example, if my cluster has 24 virtual CPUs in it, the Dataproc premium will be 24 cents per hour. Now, I did say we do per-minute billing. If you use less than an hour, we fractionally charge you. The math isn't that fun, so I'm not going to go into sub-hour math, but we do express it in a per-hour rate. We have a 10-minute minimum for Cloud Dataproc clusters, so anything over 10 minutes will be billed at the minute-by-minute rate. And these charges are in addition to the charges that you incur for running the Cloud Dataproc cluster, which includes typically compute and storage charges. So you might be somewhat sold on the idea of running Spark and Hadoop on a cloud because it gives you elasticity, it gives you cost advantages, it gives you flexibility. But you might be asking yourself, why Cloud Dataproc specifically? Well, that's a good question, and I want to answer that. So with Cloud Dataproc, you get several things that you can't even find in other cloud environments. First of all, we're really, really fast. I mentioned this a few times, but I'll mention it again. Usually on average, clusters take 90 seconds or less to start up. This means you're not waiting around for minutes or hours for clusters to become available. But it also means that in the course of, say, a year, you're not paying for time for a cluster when it's just booting up. You're paying less for a cluster that is not able to be utilized. Second, we have minute-by-minute billing. This is hugely important because if you have a Spark or Hadoop job that, for instance, takes 37 minutes, you should pay for exactly 37 minutes, and you can. You create the cluster, you submit your job, and once the job's done, you simply delete your cluster. We're not going to round up to the nearest hour, and we're not going to ask that you commit to long-term multi-year deals. All of these pricing advantages are built into Cloud Dataproc. We also give you a lot of really flexible compute options to try and even lower your cost further. For instance, we give you access to preemptible virtual machine types and also custom machine types. These are two compute options which allow you to take advantage of drastically lower compute prices for resources that are available based on spare capacity, that's preemptible VMs, or custom virtual machine sizes where you can choose specifically the amount of RAM and CPUs that you want in your cluster. These are both levers that you can use to further optimize the cost advantages on Cloud Dataproc specifically. Cloud Dataproc also tries to update itself very frequently. So the Apache Spark and Hadoop ecosystem is rapidly moving. And in many cases, customers are very excited to take advantage of the latest and greatest enhancements to Cloud Dataproc. With Cloud Dataproc, we try to roll out these new additions to the Apache Spark and ecosystem, whether they're new products or they're updates to existing open source components, as quickly as practically possible. That way you can take advantage of the tools that you really might want to use. Ultimately, you might be asking yourself at this point, how can you specifically use Google Cloud Dataproc? Well, that's a good question. There's really three ways. The first is the Google Developers Console. This is the web user interface that you can use to interact with the entire of Google Cloud. So you open up a browser window, and you can create Cloud Dataproc clusters in one click. You can submit jobs in one click, and you can delete your clusters in one click. This is all done through your browser. It's very easy to use and not complicated. We also use the same web user interface as other Google Cloud Platform products. There's not a disjointed experience between the user interface that is managing your cluster that's in your browser and the user interface for something like your enterprise data warehouse if you're using Google BigQuery. It's unified together. Second, we offer the Google Cloud SDK. This is a set of command line utilities that you can use to interact with Google Cloud Dataproc in a terminal window. So with one command, for example, I could go create a Cloud Dataproc cluster that has 2,000 cores in it without a lot of work. Third, the two things I just mentioned, the Developers Console and the Cloud SDK, they're both built on top of our really powerful Web API. This Web API allows you to manage clusters and jobs easily. You could build your own applications or script out your Apache Spark and Hadoop use based on this Web API. We provide samples for this Web API online, but it's also a fairly easy to use REST Web API. So it should be very easy for you in just a few lines of Python to create a cluster, submit a job to it, and delete the cluster when you're done. This ultimately gives you a lot of flexibility to create clusters specifically when you need to use the Apache Spark and Hadoop ecosystem. So it's easy to use. There's many reasons to use it, but what might I use Cloud Dataproc for? Well, a canonical use case, the first use case we'll talk about, is log processing. This is, for a long time, been the bread and butter of specifically the Apache Hadoop project. So in this example, say I have a bunch of web logs that live in Google Cloud Storage, and I want to aggregate these web logs to figure out how many visitors I got on my site per day and the country that they came from. With Google Cloud Dataproc, you could create a cluster, use Apache Hadoop, read the data from cloud storage, process the data on your Cloud Dataproc cluster, and then write the results back to Google Cloud Storage. You might also have a BigQuery table where you store this data, or a Cloud SQL table, or you might want to put it in Bigtable, which is HBase compliant. All of these are options. The point being is that you can use Cloud Dataproc to easily process your log data and use the very familiar Apache Hadoop toolset to do so. A second use case, ad hoc data mining and analytics. So for example, say I was really interested in taking advantage of Spark SQL, and we see a lot of interest in Spark SQL. Well, again, that very same data set that I mentioned earlier, I could create the same cluster or a different cluster and use Spark SQL to analyze my data in real time, ad hoc. Again, I can read from multiple sources within Google Cloud, and I can output to many sources in Google Cloud. In this case, I could also use a tool to help me. So for instance, I might be really interested in using Apache Zeppelin to write Spark SQL to examine and analyze my log data. All of that's very possible on Google Cloud Dataproc. Third use case. This is a bit more of a leading edge use case. So let's talk about machine learning. We see a lot of interest in Spark ML specifically. Since Google Cloud Dataproc provides you a vanilla Spark and Hadoop ecosystem, this means that you can take advantage of something like Spark ML on Cloud Dataproc easily. So again, I could create a cluster. I could write a job which took advantage of the Spark ML libraries, maybe to, for instance, try and figure out which countries my visitors might come from tomorrow based on the day of year and by hour. All of that's possible within Spark ML and possible within Cloud Dataproc. You can read from many sources, you can write from many sources. It gives you access to the really powerful Spark ML platform in the much larger Google Cloud context, also easily and cost effectively. Now that I've run through some use cases for Google Cloud Dataproc, I want to go ahead and run through a demo to show Google Cloud Dataproc in action. In this demo, we're going to do a few things. We're going to create a cluster. We're going to query a large set of data that is stored in Google Cloud Storage. We're then going to look at the output of the queries that we're running, and then delete the cluster once we're done with our queries. The data that we're going to query is a New York taxi data set. So the New York Taxi and Limousine Commission, along with Uber, have released a data set of trips from 2009 to 2015. The original data set is in CSV format and is about 270 gigabytes. When we query the data, we're going to create an external table that is pointing to the data in Google Cloud Storage. And then we're going to run 4 queries on the entire data set. So let's get started. I have my web browser open to the Google Developers Console. The Developers Console is the web interface to use the Google Cloud Platform products. Specifically, I'm in the Google Cloud Dataproc section of the Developers Console. On the left, you can see all of the products that are offered in Google Cloud Platform, and you can find Cloud Dataproc in the Big Data section. When you look at the Cloud Dataproc section, you'll notice that there's 2 top-level concepts, clusters and jobs. Clusters are Spark and Hadoop clusters that are built on Compute Engine, and that's the backbone of your Cloud Dataproc cluster. Jobs are Spark, PySpark, or other types of jobs that you want to run on your clusters. We're going to go ahead and start off by creating a cluster. I'm going to click this Create Cluster button, and we're taken to a form where we have to fill in just a little bit of information about our cluster before we can go ahead and create it. First, we're going to give the cluster a name. In this case, I'm just going to call this cluster demo. Second, we choose a zone where we want to create our cluster. Cloud Dataproc is available in every zone where we have Google Compute Engine, so you have quite a few options here. In this case, I'm going to go ahead and choose US East 1D, just because I like that zone. Next, we choose the Compute Engine types that we want to use for our master and worker nodes. We support most of the available Compute Engine templates, and if I were doing this on the command line, I would actually also have option to create my cluster with custom VM types. In this case, I'm going to go ahead and choose an N1 standard 16 for the master node, and let's use some N1 standard 8s for the workers. I'm not going to be using persistent disk, so I'm going to go ahead and trim down the amount of persistent disk that I want to attach to my cluster, because I'll be using Google Cloud Storage. And let's go ahead and create a modestly sized cluster here. So we're going to create 200 nodes, each with 8 cores, for a total of 1,600 yarn cores and about 4.7 terabytes of yarn RAM. If I click the button to show the additional options, you'll see that I can do some more advanced things when I create this cluster, such as add preemptible worker nodes to it. I can change my networking settings. I can choose to use different Dataproc versions, which are the bundled components of Spark and Hadoop and other things that are installed on the cluster. In this case, it'll default to the latest, which is 1.0. I can also choose to run what are called initialization actions. I'm going to go ahead and install initialization action to install one of my new favorite new up-and-coming projects on the cluster, which is Presto. So in this case, I'm going to go ahead and give a location of where my initialization action is stored. And this shell script will go ahead and install Presto on my cluster when I create my cluster. You'll see at the bottom there are two options here. One will show me the equivalent REST that can be used to create this cluster using the Google Cloud Dataproc REST interface. And as you can see, it's a very expressive but not incredibly complicated REST interface. This makes it really easy to build applications that use the REST interface. You can also see that there's an equivalent command line button that gives the equivalent Cloud SDK command line action to create this cluster from the command line. We're going to go ahead and click Create here. And now the cluster is in the process of provisioning. While that's happening, let's go ahead and look at the concept of jobs in Cloud Dataproc. So within Cloud Dataproc, when you go to submit a job, there's only a few options that you'll have to fill in. First, you have to select the cluster on which you want to run the job. In this case, I have just one cluster in my project, which is the demo cluster. It's in the process of provisioning right now. Second, you choose the type of job you want to run. And we'll come back to this as we run a real job on this cluster, but you'll see that we support some of the most common job types on this cluster, such as Hadoop, Spark, PySpark, Hive, Spark SQL, and Pig. Depending on the job type that you select, your cluster will automatically filter the form for the options that are relevant for that job type. So you can see that I chose PySpark, and now the options in this form are specific to things that a PySpark job would need. If I change this to Hive, for example, it then changes the form to options that are relevant to Hive. So I could say that I want to run a query file, and it will then ask for the location of the query in cloud storage. Again, if I enter, this is just going to be a test here. Let's just say I have a bucket, my bucket. There's options at the bottom here. You can see the equivalent REST. Again, this makes it very easy to develop applications that use the Google Cloud Dataproc REST API. So that's an overview of jobs. We're going to come back and run a job on the cluster that we're creating here. And what we're going to do is we're going to run a job that is going to process a specific data set that I find really interesting. So if we look at our cluster, when you open a cluster, you'll get some basic levels of information here. You can see the overview of the cluster. And as a note, this check mark indicates that the cluster is now available. So in the time that I covered the jobs with you, this 1600 core cluster went from just start to completely ready to go, which is pretty quick considering the size of the cluster. You can also see which jobs are running on this cluster. Right now, there are no jobs running on the cluster, but that will change soon. You can see the virtual machine instances that are attached to the cluster. So in this case, you can see all 201 virtual machine instances. We also give you the option to SSH into the master node. And this is really useful if you want to do things specifically on the command line. So we try and make things very easy to do with Cloud Dataproc. But if you wanted to log into the master node and do something like submit a Spark job with Spark Submit, or you wanted to manually tune the cluster, or you needed to do anything very specifically deep down on the cluster, you easily could. And you can see that I've now launched an SSH window and I'm connected to my master node simply from my web browser. And if we try and open Spark Shell, you'll see that this is acting like a normal Spark and Hadoop cluster because it is a normal Spark and Hadoop cluster. So let's go back to our project here, and then you can see that we can both see and also edit configuration details about this cluster. So for example, we could say we want to add 5 more nodes to this cluster. We just want some extra horsepower. We can also add preemptible nodes. Likewise, I could remove worker nodes and remove preemptible nodes from this section as well. So my cluster is going to go ahead and update itself. Let's run an example job. So I'm going to go ahead and submit a job, and we'll choose the cluster. From job type, I'm going to run a pig job. And specifically what I'm going to do is I'm actually using pig to execute a set of shell scripts and then an SQL query. So I'm not really using pig directly. I'm actually using pig to run a bunch of queries in Presto, which I will show you in a minute. I'm going to go ahead and choose where my pig script lives. In this case, I'm going to choose a query file, and we'll go ahead and put in the location. Okay. And the cloud storage bucket, you can see here that I'm using, my Dataproc cluster is connecting directly to the cloud storage bucket. So Dataproc is built in with a bunch of connectors to talk to other cloud storage products, cloud products in general, including cloud storage, Bigtable, BigQuery. So you don't have to manually set up your cluster. We create a cluster that is already highly integrated with the cloud platform. And I'm going to update my file to point to the right file there. And we'll go ahead and click submit. And now this job will submit. It's going to take all of the details and the query file itself and send it to the cluster. The cluster will use Yarn, and it will go and execute my demo. And it will use Presto, which we installed on this cluster when we created it. Now, with the job, you can see that we stream the output of the job through Cloud Dataproc. So this is actually really great for following along with the job, debugging a job. So you can see that as new information comes in from this job, it is piping directly to the Google Developers Console. If I ran this on the command line, the output would be piped directly to the command line, which is really great. Now, while that job's running, I just want to show you that when we create Cloud Dataproc clusters, we're building on the basic building blocks of Google Cloud Platform. So in this case, I've gone to the Compute Engine section of the Cloud Platform, and you can see all of the VMs that are a part of my Cloud Dataproc cluster. So I just want to show this to you so you can see that Cloud Dataproc is built on top of the really awesome technologies that are a part of Cloud Platform, which if you want, you can interact with specifically, but we're not trying to abstract away too much from you with Cloud Dataproc. We try to make things easy, but also give you ultimate flexibility and power with your Spark and Hadoop clusters. If we go back to the Cloud Dataproc section here, we can see the cluster that I have created. And you'll see that the cluster will show you aggregate monitoring data. We could look at different metrics here, like disk operations and such. Let's go ahead and go back to the pig job that is running. Let's go ahead and open that job. And you can see that we're getting real results now. So if I were you, I would be asking, what the heck are we actually doing in this job? So there's a set of data published by the New York Taxi and Limousine Commission and Uber. The data set is all of the taxi and Uber trips from 2009 to late last year. Uncompressed, the data is about 275 gigabytes. So what we're doing is this job actually created a table that is looking at this data in Google Cloud Storage. And then we're using Presto to run these 4 queries against the data. So essentially, we're running 4 queries against 275 gigabytes of data stored in cloud storage. You can see some of these queries are very simple, such as looking at the cab type and the count of trips by cab type. Some are a little bit more complicated, such as looking at the average trip distance per year by the number of passengers. If we go back to the job output, you can see that the job is complete. So in less than 3 minutes, we went and processed all of that data in cloud storage using Presto. And all of the data was piped and streamed back to the developers console. Job output is also put into Google Cloud Storage, which makes it very easy for you to get at output from your jobs, such as logs or debugging information or whatever the driver output of your jobs may be, with minimal hassle. So at this point, we have now created a very large cluster. We've run a job on it that's processing a modest amount of data, and we're done. So With Cloud Dataproc, one of the core value propositions is you don't need to keep clusters around if you don't have work to do. And in this case, our job is done. So let's go ahead and just delete the cluster. Now the cluster is going to go ahead and delete the resources, such as the virtual machines and all the Dataproc machinery that's supporting the cluster. And once deleted, we won't be charged for the cluster. So we're not going to go pay for a Spark and Hadoop cluster that we don't actually have work to do on. Interestingly, if you look at this cluster ran for the minimum of about 10 minutes. So the overall price for this cluster and processing the job was about $12. If you look at competing services from other managed Spark and Hadoop offerings in other clouds, typically you'll see that the prices will range from about $45 to $80. So with Cloud Dataproc, our low rates and also permanent billing give you a substantial cost advantage when processing Spark and Hadoop workloads in the cloud. So if you decide to use Cloud Dataproc, there's a few tips and recommendations that we want to share with you to help you most effectively and powerfully use Google Cloud Dataproc. So the first, splitting up jobs into multiple clusters. As an artifact of how many people often run the Spark and Hadoop ecosystem, you often see large multi-tenant clusters running on-premise where people are sharing resources and all jobs are running on one or just a few large clusters. Well, with Cloud Dataproc, you can split things up a bit, and we usually encourage you to do so. So for example, if I have several different groups that are using or have jobs that are running on my cluster, I can create clusters for each one of those groups. This allows me to do things like know which resources and how much resources each group are using. It allows me to provision and secure the clusters based on the groups using those resources. It also allows me a lot of flexibility in terms of my capacity and utilization. So instead of running one really large cluster, we strongly encourage you to break your jobs apart as much as possible and run your jobs on smaller clusters. That gives you maximum flexibility in terms of cost, ease of use, organizational control. It's one of the many benefits of running in Google Cloud Dataproc. Second, with Cloud Dataproc, since you can create as many clusters really as you want, and they're quick to start and stop, it gives you a lot of flexibility to easily create development and production environments. So if I want to go develop a bunch of new Spark, I could, for example, go create a cluster that's my development cluster. Since Cloud Dataproc is integrated with the rest of Cloud Platform, I could go read the same data that my production cluster is reading. I could develop my new scripts. Once I'm done, I save my work and turn the cluster off. My development and production environments are isolated. I don't need to worry about bringing down my production environment. Or, for example, say I wanted to use a new version of Spark, like Spark 2.x. I could create a development environment, bring my existing code, test it out, see what works, what doesn't work, adapt it, all without worrying about changing or needing to modify your production environment. Third, we really encourage you to use Google Cloud Storage. So traditionally, people are very familiar with HDFS, the Hadoop file system. HDFS is usually built on disk and lives very close or on the cluster hardware itself. With Google Cloud Storage, you get a tremendous number of benefits. First, Google Cloud Dataproc can treat cloud storage as if it were HDFS. We have a connector that comes with the cluster that allows you to address cloud storage as if it were HDFS. Cloud storage offers a number of benefits over HDFS. You don't have to do things like worry about replication. It has really awesome networking and distribution of files. It's highly monitored, and it's also living outside of your cluster. This means that you can have multiple clusters looking at one GCS bucket or one GCS location. It also means that as you create and destroy clusters, you don't have to worry about moving data in and out of your cluster. So if I, for example, want to process a bunch of my web logs, I can create a cluster, read the data from GCS, process my data, write the results back, and I don't need to worry about copying the data to my cluster with the HDFS, running my job, and then copying the data off. When you create a Cloud Dataproc cluster, we do provision HDFS with a cluster. In many cases, this is used for temporary operations. You could use it as HDFS if you want, but cloud storage offers a number of benefits over HDFS, which is usually why we recommend that you use cloud storage over HDFS when you're using Cloud Dataproc. So with Cloud Dataproc, you can create and scale and delete clusters whenever you want. And we highly encourage you to do that. There's no need for you to keep a cluster around if you don't have work to do. So if you have a job and you only need to run that job, create the cluster, run the job, and turn the cluster off. Again, since clusters are fast and we bill by the minute, there's not a big need to keep around resources that you don't need. We really recommend that you take advantage of the ephemeral nature of Cloud Dataproc for both your ease of use and cost advantages. The Apache ecosystem is pretty big. And with Cloud Dataproc, we install some of the most common Apache components on clusters. Since we build off of Apache BigTop, there's a whole lot of components that are available to you. And typically you can install these components with initialization actions. And we have a repository on GitHub to allow you to install some of the most common Apache components. But you can also do things like an apt-get install, which will install these components from our precompiled BigTop repository. Since we build off of the open source itself, it also allows us to, as I previously mentioned, offer you new up-to-date versions of these open source components fairly quickly. And we encourage you, when you're using Cloud Dataproc, to take advantage of its ephemeral nature to try out these components, to see what works. You can take advantage of new releases in Spark and Hadoop without worrying about breaking your existing production workflows. So if you're creating data processing applications on Google Cloud, and you want to take advantage of the Apache Spark and Hadoop ecosystem, Cloud Dataproc is fast, easy, and cost-effective. But there's a few other products that you may want to consider in your journey in creating data processing applications on Google Cloud Platform. First, you may want to take a look at Apache Beam and Google Cloud Dataflow, especially if you're interested in stream processing. The Apache Beam model and tools are designed with stream processing in mind, with really powerful semantics for stream processing pipelines. They do things like allow you to do windowing on your data and get early speculative results and late results and aggregations very, very easily with minimal amounts of code. The Cloud Dataflow service is designed to run Apache Beam pipelines in a highly managed, no-ops environment. So you have your job, and you simply submit it to the Cloud Dataflow service. There's no clusters to worry about. You don't need necessarily to worry about scaling. It's really a very hands-off experience, and it's really great for streaming. So if you're interested in streaming, I highly recommend that you give Apache Beam and Cloud Dataflow a look. If you need an enterprise data warehouse or a large SQL query engine, I highly recommend that you look at BigQuery. BigQuery is a great way to store a lot of your data in something that is very similar to an enterprise data warehouse and have access to a really powerful SQL analytic engine to go introspect and look at that data. With BigQuery, you can, for example, run a query where you would need thousands of cores, thousands of CPUs in just a matter of minutes. You could get those cores in just a matter of seconds with BigQuery. So it allows you to process large volumes of data using SQL, which many people know and are comfortable with, in a very safe and contained and easy to use environment. So if you need an enterprise data warehouse or you want access to a really large, persistent, high-performance SQL engine, I highly recommend that you look at BigQuery. Third, if you're used to HBase, I highly recommend that you look at Cloud Bigtable. Cloud Bigtable is a service in Google Cloud Platform which provides an HBase compliant API on top of it. This is really great because it means that your cluster, which you want to speak HBase, lives outside of your Cloud Dataproc cluster. It also means that you can have multiple clusters interacting with HBase, and you don't worry about squandering resources on your Cloud Dataproc cluster simply to run HBase. So ultimately, I've talked about how Cloud Dataproc is fast, easy, and cost-effective. I've also talked about how it's integrated with a Google Cloud Platform. I want to wrap things up on how you can get started, and then the things that you can remember, and if I were to say you only had 30 seconds to remember the most salient points in this presentation. To get started with Cloud Dataproc, it's really easy. If you have a Google Cloud account, you can simply create a project if you don't have one already, and go to the Cloud Dataproc section in the Google Developers Console and get started. You can create a cluster in one click. Typically, you don't need to change almost any of the options to get started. If you have a Spark or Hadoop job that you want to run, again, in one click, you can take that job and run it on Cloud Dataproc. If you want to use the Cloud SDK, you can use one command to create clusters from 3 to thousands of CPUs. Again, it's also one command to submit jobs to that cluster. So it's very easy to get started. And this is, again, why it's very easy to lift and shift your existing data and jobs to Google Cloud Dataproc. So ultimately, this means that Google Cloud Dataproc is a fast, easy, and cost-effective way to run Spark and Hadoop, but it's also a well-integrated way to run the Apache Spark and Hadoop ecosystem in the greater context of the Google Cloud Platform. You have access to all of the powerful tools of the cloud platform and the immensely powerful and popular Apache Spark and Hadoop ecosystem joined together. Now, if you only remember 3 things from all of this, first, you should remember that Cloud Dataproc is fast. Clusters take, on average, less than 90 seconds to start. So you're not going to wait around for a long period of time to create or destroy your cluster. Second, it's easy. Since we wrap the creation and editing and deletion of clusters, and also the jobs that you want to submit to that cluster, you don't need a team of engineers to simply sit on the infrastructure to use Apache Spark and Hadoop. Third, it's cost effective. We have low rates for a Google Cloud Platform, and we also bill by the minute. So you're paying for exactly what you use. You're not locked into long-term contracts. You're not guessing about what your capacity might be or need might be in months from now. You simply can pay for exactly what you need to use today. With that, I want to thank you very much. Have a great day.